All right, let's talk about something really cool. Today, we're going to unlock a major capability in the AI world: how to take those huge, powerful language models and run them right on your own computer. I mean, have you ever looked at one of these amazing AI tools and just thought, man, I wish I could use this without being hooked up to the cloud, without an internet connection, and with total, complete privacy? Well, guess what? You absolutely can. And you know what? It's probably a whole lot easier than you think. In this quick explainer, we're going to walk through the exact steps to get you up and running with what is pretty much the go-to tool for local AI. Okay, so let's dive right in. First things first, what is llama.cpp? And why has it become like the engine for the entire local AI community? So at its heart, llama.cpp is this super efficient C and C++ library built for one single purpose: running large language models as fast as possible. The real magic here is its simplicity and just how well it performs. It's been designed from the ground up to just work with minimal setup on the computer you probably already have. And its versatility is really why it's blown up. It's been super optimized for all kinds of hardware. We're talking everything from Apple Silicon to regular CPUs and, of course, NVIDIA GPUs. It uses this really clever trick called quantization to basically shrink models way down. It can even split the work between your CPU and your GPU. And maybe the best part, no external dependencies. That just means it's incredibly lean and super simple to install. All right, so hopefully you're sold on the why. Now let's get to the how. The project gives you a few really straightforward ways to get it installed, and we're going to look at the three most popular paths. So you've got options. You can use a simple package manager, which is perfect if you just want to get started fast. Or you could use Docker for a nice, clean setup that works the same everywhere. And of course, for the power users out there, you can build it right from the source code to get every last drop of performance. Okay, if you're on a Mac, it literally does not get any easier than this. Seriously. You just open your terminal and type brew install llama-cpp. And that's it. You're done. Homebrew takes care of everything, and you are ready to move on. Now, what if you hop between different operating systems? Or maybe you just like to keep your projects tidy and separate? Well, that's where Docker comes in. It's the perfect solution. You just pull a pre-built container that has everything all set up, and you know it's going to run exactly the same no matter where you are. And finally, we've got the power user path. This is for all of you who want to squeeze out every single bit of performance or maybe enable some really specific hardware optimizations. Building from source gives you total control over the whole process. Awesome. So the software is installed, we've got the engine, but an engine is pretty useless without some fuel. So now we need to get a model for llama-cpp to actually run. Okay, this is a really important point, so listen up. Llama.cpp doesn't use the standard model formats you typically find on, say, Hugging Face. It needs models to be in a very specific, highly optimized format called GGUF. So what's the deal with GGUF? Well, it's all built around this process called quantization. The best way to think about it is like compressing a huge, high-resolution photo into a much smaller JPEG. It's the same idea. It cleverly shrinks the model's file size and how much memory it needs. We're talking often by more than 75%. Now, you might lose a tiny, often unnoticeable bit of quality, but the trade-off is huge. You get to run these gigantic models on a normal computer. It's an absolutely fantastic deal. Now, I know what you're thinking. That sounds complicated, but trust me, the team has made this so easy. You don't have to manually convert a thing. There's a built-in tool that lets you download a compatible GGUF model directly from the Hugging Face hub. You literally just point it at the model you want, and it handles everything: the download, the conversion, all in one single command. All right, we have the engine, we have the fuel. Now it is time for the payoff. Let's start our very first conversation with an AI that is running 100% on our own machine. To do this, we're going to use a tool called llama-CLI. It's super simple. You just point it to the model file you just downloaded, that's the M flag, and then you add CNV to let it know you want to have a chat. And boom, just like that, you were talking to a powerful AI. Think about this for a second. There is no data being sent to some server in the cloud, no one is logging your questions, it is completely, totally private, and it's all happening right there on your computer. How cool is that? Okay, so a command line chat is awesome, but what if you want to build actual applications on top of your local model? Well, that's where llama-server comes into the picture. This thing can turn your machine into your own private AI powerhouse. The llama-server is honestly a game changer. It spins up a web server on your computer that pretends to be the OpenAI API. What does that mean? It means any tool, any app, any script you have that's built to talk to OpenAI can now talk to your local model instead, and you don't have to change a single line of code. Plus, it supports multiple users and has all these advanced features to get you faster responses. It's perfect for building your own custom apps. And starting it up is just as easy as the chat tool. You run the llama-server command, point it at your model file, and bam, instantly you have a personal AI API running on your local network, just waiting to power whatever you can dream up. And this is the really cool part, because llama.cpp is so good at what it does, so efficient and so foundational, it's become the engine for a huge ecosystem of other tools. You know those popular apps like LM Studio, Llama, and Yawn? They all use llama.cpp under the hood. So do tons of libraries for Python, Node.js, you name it. Which really brings us to the final and most important question of all. Now that you have the power to run a state-of-the-art AI privately and efficiently on your own hardware, what are you going to build with it? The possibilities, well, they're pretty much endless.